So students, we are going to a very important part of this particular chapter. One a particular section where even a board question can be expected. It's very important, sure question section. So we are looking at how light travels through a prism, and or to put it in a specific manner, the refraction of light through a prism is this particular section dealing with. Before going into the details, let's look at some surface features, some features of a prism. And now here we can see a prism, and I can see that a prism has, if you put it like this, and trace the surface like this. So I am tracing the surface. You can see it's a triangle, and interestingly, so a prism has two triangular faces. So there are two triangular faces. So two triangular faces, and if you put the prism like this, and if I trace it, you can see that it's quite a rectangle. So and if you look at the prism, that so that you have 1, 2, 3. So there are 3 rectangular faces. So to repeat, so here and here 2 triangular faces, and here, here and here. So you have 3 rectangles. So a prism has 5 faces, 5 surfaces. 2 of them are triangular, and the rest 3 are rectangle. Now there's an angle formed between this. So you can see that these 2 faces, there's an angle over here. This angle is which is called the angle of the prism. So that's about the surface features of a prism, and let's look at how light passes through the prism, a very important section. Now we have the incident ray, that is this P is the incident ray, and of course rays coming from air entering the glass prism, and as soon as it enters the glass prism, it gets refracted away from the normal, and it's going on like this. So you can see that EF is the ray, refracted ray going through the glass prism, and of course I is the angle of incidence and R is the angle of refraction. And on the other side, when the refracted ray, the ray which is going through the glass prism, when it re-emerges into the air, you can see that you have the angle E, which is the angle of emergence, and you can see the emergent ray, that is Fs. Now there is a very, very important thing happening here, which is quite different from a glass slab, and that's, so you have let's look at 2 surfaces to get the idea. So we have 2 surfaces. The two important surfaces in this discussion is the surface. The first surface, that is AB, and the second surface AC. So AB, so what are 2 media, air and glass? AC, the 2 media, glass and air. So at surface AB, this surface, the light ray enters the prism, that is light ray enters from air to glass, and of course it bends away from the normal. You can see that the light ray is bending away from the normal. At here, the light ray is bending away from the normal. What happens on the other side? That's when the refracted ray emerges outside. The interesting part is that when at surface AC, when the light emerges from glass to air, there also the light ray is bending away from you. You can see the normal, and the light ray is bending away from the normal. Now what is the key point here? Now in the previous physics chapter of the science section, we have learned that if you are dealing with a glass slab, so this is the incident ray, that is PQ is the incident ray. So this is the refracted ray, and RS is the emergent ray. But the point is that the incident ray, the refracted ray is away from the normal, but on the other side, as far as the glass slab is concerned, when the rays emerging from the glass towards the air, that emergent ray is towards the normal, not that point, towards normal. And of course, these two rays, that is PQ, is parallel to ours. Now, that's not the case with the prism. In the prism, both the rays, both the incident ray and the emergent ray is actually bending away from the normal. And what is the reason for it? The reason for it is the unique shape of the prism, the geometry of the prism. The unique shape of the prism is the reason for that. And this gives rise to a very important angle, which is this angle. It's called the angle D. Actually, the angle D should be somewhere in the midpoint of the prism, something like here. So angle D is the angle of deviation. So what is the angle? How do you define the angle of deviation? So angle of this particular angle, so if you extend the incident ray, that is PE, like this, and if you extend the other ray, that is the emergent ray, there is a point at which these two rays will meet, and there an angle is formed, which obviously is the angle of deviation. So this angle of deviation actually is the angle at which or by which the emergent ray is getting changed or when compared to that of the incident. So the angle of the emergent ray bends when compared to that of the incident ray is the angle of deviation. So a very important point, very important angle, angle D, the angle of deviation. So that's about prism, and note that this is a very important section of this chapter where even board exam questions can be expected. Thanks.